Hello everyone, very good evening and welcome to the BYJU'S Exam Prep. This is Sanjay Rathi and now we are going to discuss Excess-3 code and what gray code. It is of GATE and ESE fundamentals and we are dealing with the digital electronics. Now, Sayan Malik, how are you guys? Okay, sorry for delay, right? Now, already we have discussed what 8421 code, 84-2-1 code and what 2421 code. These all are what? BCD, binary coded decimal, weighted code. 8421 is not self-complementary, but 84-2-1 and 2421 is what? Self-complementary code, guys. Okay, so in a previous class we have discussed. Then in first class we have discussed what? Binary number, octal number, hexadecimal numbers. Okay, and then guys in next class we have deal with what? Addition, subtraction, multiplication, division, conversion, 2's complement, 1's complement representation, sign magnitude, sign 1's complement, sign 2's complement and so on. So I think now you are ready to solve some questions, yes or no? If you are ready to solve some questions and if you are ready to give the quiz, then tomorrow we will solve number of questions from standard textbook, previous year questions, and then the day after tomorrow there will be one quiz, right? तो तैयार हो जाइए, पूरा तैयारी कर लीजिए. और number system there will be what? Quiz, guys. So 2 days time, 9 PM to 10 PM. Okay, so welcome to the BYJU'S Exam Prep, the most comprehensive app for all competitive exams, guys. Like the session, share the link of this session and subscribe our channel. Now, this is my introduction, myself Sanjay Rathi. I am having around 22 years of teaching experience and these are my achievements. I have qualified and selected for engineering services exam. These are my ranks and I have mentored more than 1 lakh students for these competitive exams. Now, digital. क्या लगता है आपको? बड़ा ही इजी सा सब्जेक्ट है सर, इसमें कौन सी बात हो गई, राइट? आप ये देखिए कि इलेक्ट्रिकल में इस बार टॉपर्स के मार्क्स कितने गए. अगर आप इलेक्ट्रिकल में टॉपर्स के मार्क्स बता दें मुझे, मतलब गेट 2023 में टॉपर्स के मार्क्स अगर आप बताएं तो आप मान सकते हैं कि कोर जो आया था मशीन पावर सिस्टम पावर इलेक्ट्रॉनिक्स थोड़ा टफ था, राइट? और तब कुछ बच्चों ने मार्क्स गेन किए कहां से? डिजिटल, एनालॉग, नेटवर्क, कंट्रोल. तो जितने भी साइड के जो सब्जेक्ट्स है ना, जिसको आप मानते हो कि बेसिक सब्जेक्ट है, कोर तो आप मानते हो मशीन पावर सिस्टम पावर इलेक्ट्रॉनिक्स, तो इस सब्जेक्ट ने हेल्प की. सिमिलरली फॉर इलेक्ट्रॉनिक्स स्टूडेंट, इंस्ट्रूमेंटेशन ब्रांच, कंप्यूटर साइंस ब्रांच, आपको ईच एंड एवरी क्वेश्चन बनाने हैं फ्रॉम डिजिटल. आपको लगता है इट इज इजी, बट व्हेन वी आर डीलिंग विद व्हाट? कॉन्सेप्चुअल क्वेश्चन, तो आपको लगेगा कोई भी सब्जेक्ट इजी नहीं है. प्लीज ट्राई टू अवॉइड द सिली मिस्टेक्स. Now we will discuss some important numericals on digital and Excess-3 code and gray code. Okay, then this is our take a step towards success in GATE. National scholarship test for GATE exam, get up to 90% off on your program. This is what? This is for you. आप अपने जूनियर्स को बोल सकते हैं अगर ऑलरेडी आपने एडमिशन ले लिया है, अदरवाइज आप खुद ज्वाइन कर सकते हैं और अपने फ्रेंड्स को भी बता सकते हैं. गेट अप टू 90% ऑफ ऑन आवर प्रोग्राम. डेट नोट कर लीजिए, दिस संडे 16 अप्रैल एट 12 PM. यू कैन रजिस्टर नाउ फॉर दिस स्कॉलरशिप टेस्ट, गाइज. ओके, देन सेकंड इंपॉर्टेंट थिंग, Excess-3 code. What is the Excess-3 code? Right, in a previous class we have discussed about self-complementary code. Self-complementary code means directly we can find the 9's complement by simply complementing each bit 0 to 1 or 1 to 0. For example, this is written here, self-complementary code. The 1's complement of an Excess-3 number is the Excess-3 code for the 9's complement of the corresponding decimal number. It is an unweighted code. Unweighted code. Then, for example, this is the 8. What is the 8 in binary or binary coded decimal? 8 is written as 8421, that is 1000. Now add 3. When we are adding 3, 8 plus 3 is what? 11. This is the code for 11, 1011, but it will represent what? 8 here. So this is the Excess-3 code for 8. Similarly, 6. What is the 6? 0110. 0110, that is the 6. 0110, that is the 6. When we are adding the 3, the code will become 9. The 9 is the Excess-3 code for what? 6. Now, what is the meaning of the self-complementary code? Very simple. This is the decimal. This is the BCD representation. What is the Excess-3? Add 3, 0, 0, 1, 1. 1, add 3, it will become 0, 1, 0, 0. Add 3, it will become 0, 1, 0, 1. That is the 5. Code 2 is what? 5. Excess-3. Add 3, it will become 6. Add 3, it will become 7. 8. 9. Then what? 10. And then what? 11. And then what? 12. Then what? 12. This is what? 12. 1, 0. What is the 12? Give me 1 minute. One zero zero one, that is the code for 9. Add 3, what is the 12? 1101. 1100. 1101. This is the code for 9. 9 means in 8421, it is represented as 1001. But when we are adding the 3, what is the Excess-3 code? It will become 1100. That is for what? 9. That is for 9. Now, what is the meaning of the self-complementary code? What is the 9's complement of 2? The 9's complement of 2 is 9 minus 2, that is the 7. 9's complement of 2 is what? 7. Now, what is the code for the 2? The Excess-3 code for the 2 is 0101. Now, find the 1's complement of this 1010. And now 1010 is the code for what? 7. Watch this. 1010 is the code for 7. So simply finding the 1's complement, you can find the 9's complement, and that's why it is called self-complementary code. Now you can check for 1 also. What is the code for 1 here? 0100. Now this is the code for 1. What is the 9's complement of 1? 8. What is the code here? 1011. And this is the code for what? 8 here. This is the code for 8 here. So you can similarly check 0. What is the 9's complement? 9. It is 0011. It will become 1100. That is the code for 9. And that's why it is called what? Self-complementary code. It is unweighted code. Unweighted code means the weight of this position is not fixed. For example, in case of okay, 8421. Suppose you want to write the 9, it will become 1001. 84 minus 2 minus 1. If you want to write the 1, 8 plus 4, 12, 12 minus 2, 10, 10 minus 1, 9. This is the code for 9. 2421. If you want to write the 9, 1111. 4 plus 2, 6 plus 2, 8 plus 1, 9. But in Excess-3 code, if you want to write the 9, first of all, write the 9 and then add 3. 110 carry 1, 110 carry 1, 1. And that is the 1100. This is the code for 9. What is the weight? There is no weight. Means what? What is the weight of this position? Weight of this position, weight of this position, weight of this. There is no weight. But here we have the 2421, 84 minus 2 minus 1, 8421 and so on. And that's why it is a self-complementary code, but it is unweighted code. Okay. So that is about the Excess-3 code. Now, next one is what? Gray code. Gray code, right? It is a non-weighted code and it is not suitable for arithmetic operation. आपको मैंने पिछली क्लास में बताया था जितने भी सेल्फ कॉम्प्लीमेंट्री कोड है, these codes are used for what? Subtraction. These codes are used for subtraction. So we are using the 9's complement method for subtraction. Okay. Now, अब आती है बात gray code. First of all, remember it is not a binary coded decimal. It is not a binary coded decimal. It is a non-weighted code and it is not suitable for arithmetic operation. First, non-weighted code and it is not suitable for arithmetic operation. For example, binary. Binary is what? Weighted code. Means each position has weight 8421. For example, 4-bit, then 8421. For example, 5-bit, 168421. This is the weight of the position. Weight of the position. But in a gray code, it is a non-weighted code and that's why it is not suitable for arithmetic operation. So what is the use of this? It is also called cyclic code and the difference in 1-bit position only, unit distance code. It is also called reflecting code. Now, we will get the idea why it is called the cyclic code, why it is called the reflecting code and so on. Okay. Now, watch this. Suppose you want to write the gray code. Just like a binary. For example, if you have the 1-bit only, then there will be the 2 to the power n combination. That is the 2 combination only. Now, you can write the binary, you can write the gray code like this 0 and 1. This is the 0 and 1, only 2 combination. In binary again 0 and 1, in gray code again it is a 0 and 1. Now, if you have n is equal to what? 2-bit. Then there will be the 4 combination. Then how we can write the gray code? How we can write the gray code? First of all, remember the binary here. What is in binary? If it is 0, 1, if it is the 2-bit 0, 0, 0, 1, 1, 0, 1, 1, if it is a 3-bit 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. We are writing like this. This is the binary code. Watch the binary code and watch the gray code. Now we can understand what is the difference between these two codes. When there is a 3 bits, we are having the total 8 combination. When there is a 2-bit, we are having the 4 combination. When there is a 1-bit, we are having the 2 combination. Similarly, the combination will remain same. What is the way to write? If it is a 1-bit, write like this. This is the first one. If it is a 2-bit, then always write like this. 0, 1. First of all, write 0, 1. Now, what is the reflection of this? 1, 0. What is the reflection of 1, 0? 0, 1. Mirror image 1, 0. This is called reflection. Now, put 2, 0 here, 2, 1 here. And that is called what? Gray code. Now, you can watch. What is the difference between this? Now guys, here 0 is represented by 0, 0, 1 is represented by 0, 1, 2 is represented by 1, 0 and 3 is represented by what? 1, 1. But here 0 is represented by 0, 0, 1 is represented by 0, 1, no change, but 2 is represented by 1, 1 and 3 is represented by what? 1, 0. 3 is represented by 1, 0. Now, watch this. Is it clear? Now, if you want to write in what? 3-bit. 3-bit means total 8 combination. Then you have to write the same code. N is equal to 3. Then 0, 0, 0, 1, 1, 1, 1, 0. First of all, write all this. Then reflection 1, 0, 1, 1, 0, 1, 0, 0. Now put 4, 0 here, 4, 1 here. And that's why it is called reflected code. And we have again 8 combination. Now, but what is the difference? It is 0, it is 1, it is 2, it is 3, it is 4, 5, 6 and what? 7 here. But in this case, it is 0, 1, 2, 3, 4, 5, 6 and what? 7. Now, what is the difference between the binary and what gray code? Watch carefully. When I am talking about the 2-bit, 0, 0, 0, 1, 1, 0, 1, 1. What is the difference? This 0 is 0, this 0 is 1. So difference of 1 here. What is the difference in these two numbers? This 0 become 1, 1 becomes 0. Distance is 2. What is the distance here? 1, 0, 1 will remain 1, 0 will become 1. That's why distance is 1. And what is the distance between last number and first number? This is the difference is 2. 1 becomes 0, 1 becomes 0. This is called distance between consecutive code. But same thing in case of gray code. This is 0, 0, 0, 1, 1, 1, 1, 0. Watch this. 0, 0, what is the distance? 1. From 0, 1 to 1, 1, what is the distance? This 0 is converted into 1. This 1 will remain 1. That is the 1. 1 will remain 1. 1 will become 0. That is the 1. And again, after 1, 0, 0, 0. That I am right here, 0, 0. What is the distance? Only 1. So when we are writing in cycle, the distance between consecutive configuration will remain 1. And that's why it is called unit distance code. It is called cyclic code. It is called what? Reflected code. तो ये है ग्रे कोड के बारे में. This is the detail about that gray code. But it is not used for arithmetic operation. Then what is the use? What is the use of this gray code? And everyone please write the gray code what? For 4-digit number. If you want to write the 4 bits. If you want to write the reflected code for 4 bit, then simple. Now watch this. 4 bit means first of all write 0, 0, 0, 0, 0, 1, same thing, 0, 1, 1, 0, 1, 0, this is the code, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 0, 0. Then reflection of this. What is the reflection? 1, 0, 0, 1, 0, 1. What is the reflection? 1, 1, 1, 1, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, and finally 0, 0, 0. And guys, now put 8, 0 here and 8, 1 here. And that is the 4-bit gray code, and that is called reflected code or cyclic code. So this is the simple way to write what? Gray code or reflected code. Then which type of question you may expect from the gray code? That is, what is the use of this? These are used in instrumentation and data acquisition system where linear or angular displacement is measured. It is used in soft encoder, input output devices, and A to D, D to A converter, A to D converters. Okay. Now watch this. This is a soft encoding, right? And use of the cyclic code. When we are moving from this sector to this sector, only the 1 bit will change. When we are moving from this sector to this sector, only the 1 bit will change, and that will reduce what? Error. That will reduce the error. Okay, we can detect the error. So when we are moving from one sector to other, because it is divided into 16 sectors, and this is what? 0, 0, 0, 0. This is the 0, 0, 0, 1. This is 0, 0, 1, 1. So only the 1 bit change. 1 bit change. Only 1 bit change, 1 bit change, 1 bit change. And finally, we are getting the 15. In case of normal binary, 15 is 1, 1, 1, 1. And what is 0, 0, 0, 0? There is a difference of 4 bit. But in case of gray code, this is the 15. 1, 0, 0, 0. And what is 0, 0, 0? What is the change of 1 bit only? Change of 1 bit only, and that's why it is called cyclic code. The gray code is used to eliminate the error problem which is inherent in the binary code. The gray code assures that only 1 bit will change between the adjacent sector. 1 bit will change between the adjacent sector. This is adjacent to that, this is adjacent to that, and so on. That is used in what? Soft encoding. Okay. Then how we can change the binary? If suppose any binary number is given, it is not possible to write the reflected code like that in every case. No doubt. It is what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and what? 15. But it is not possible every time we are writing from this number 0, 1 and that number and this number, and then finally we will reach up to this number. If any binary code is given, how we can convert it into what? Gray code. Directly we can convert it into gray code. Now binary number is converted into gray code. For example, any binary number is given. Let 15 is given. 15 is given. How we can find the gray code of this? This is the binary code. First of all, MSB will remain same. This is the MSB. Then exclusive OR of these two number. And what is the one exclusive OR with 1? 0. 1 exclusive OR with 1. What is the one exclusive OR with 1? 0. Right here. Then again this one exclusive OR with this one, and that is the result 0. And that is the code for 15 in binary, and that is the code for 15 in gray code. This is called binary to what? Gray conversion. This is what? Binary to gray conversion. You can verify another number also. For example, 7. This is 7 in 4-bit. This is 7. Now, if you want to convert it into the gray code, now this 0 will remain 0. MSB will remain same. 0 exclusive OR with 1 is 1. 1 exclusive OR with 1 is 0. 1 exclusive OR with 1 is what? 0. 1 0 0 1 0 0. It is the code for 7. This is in binary. This is in what? Gray code. You can check. What is the 7? 0 1 0 0 0 1 0 0. What is the 15 here? 1 0 0 0. Now you can verify anything. For example, 11. 11 is what? 1 0 1 1. This is in binary. Right MSB. Exclusive OR 1 0. It will become 1. 1 0 exclusive OR with 0 is what? 1. 0 exclusive OR with 1, it is 1. 1 exclusive OR with 1, it is 0. So what is the code for the 11? 1 1 1 1 0. 1 1 1 0. This is the 1 1 1 0. This is the code for 11. Code for 11. 1 1 1 0. This is the gray code. So this is the binary to what? Gray conversion. So this is written here, binary to gray conversion. How we can convert the binary into the gray? Binary to gray. Now this is the diagram, guys. This is the diagram. Let this is the binary code. This is the MSB. If it is MSB, directly it will become what? MSB of the gray code, right? This is the G4, G3, G2, G1. This is the MSB. Now this A is exclusive OR with what? B. A is exclusive OR with B, and that's why it will become G3. Then B is exclusive OR with C. That is become this, and finally C exclusive OR with D. That is, we are getting the binary to what? Gray code conversion. We are using XOR gate here. Very simple one. Now next question will be what? Gray to binary. So what is the gray to? First of all, convert it into gray code. Everyone give me the answer in comments box. Take your time and give me the answer. What is the, this is the binary code is given. What will be the gray code? 1 0 0 1 0. Everyone in comments box give your answer. What is the gray code for given binary code? 1 0 0 1 0. Okay, tell me. Yes, please. Now if you want to convert it into gray code, MSB as it is, exclusive OR of this, 1 exclusive OR with 0, 1, 0 exclusive OR with 0, 0, 0 exclusive OR with 1, 1, 1 exclusive OR with 0, 1. That is what? 1 1 0 1 1. This is the gray code. कोई आंसर आया भाई देखे? Yeah, please give me the answer in comments box. And that is what gray binary is converted into what? Gray code, guys. Now how we can convert the gray to binary conversion? What is the gray to binary conversion? If suppose this is the gray code 1 1 0 1 1 1 1 0 1 1. That this is the gray code. What is the method? MSB will remain same. MSB will remain same. Now this is exclusive OR with the second one. This result will exclusive OR with the second one. Then one exclusive OR with one is what? 0. Then this is 0 is exclusive OR with this 0. That result is here. 0 exclusive OR with 0 is 0. This 0 is exclusive OR with 1. This is become 1. Then this one is exclusive OR with this one. And what is this? 0. What is the binary code? 10010. What was the code? 10010. 10010. This is the result. This is called gray to what? Binary. First of all, this one. Then this result is exclusive OR with this. 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 And then gray is converted into binary. So same, what's this? Right, for example, it is binary. It is the gray. First MSB will remain same. This is the binary. Right, this is the MSB. Then this the B1. Actually B1 is exclusive OR with what? Actually the B1 is exclusive OR with B. You are getting the B2. Now this B2 is exclusive OR with C. You are getting the B3. Now this B3 is exclusive OR with what? D. You are getting the B4. So B1 is nothing but A. And B2 is nothing but B1 exclusive OR with B. B3 is nothing but B2 exclusive OR with C. And this is B3 exclusive OR with D. And you will get the B4. That is the result. Gray to what? This is called what? Combinational circuit. Combinational, why it is called combinational circuit? The present output depends upon the present input. We are giving the gray code as the input. We are getting the binary code as the output. There is no memory element is required. No feedback. Simply we are giving the input as a binary code or gray code, or it is converted into what? Binary. You can also give the name like this: G3, G2, G1, G0. This is the gray code, and here you are getting the B3, B2, B1, B0. This is, you can write here MSB, you can write here MSB, so that it is very clear. This is the gray to binary code converter. It is a combinational circuit, guys. Okay, so this is about the gray and binary code. Now everyone, tomorrow we will solve question. Again we will solve some questions, but tell me what is the answer. Tomorrow we will solve some question from the previous year question paper from standard textbook, like what? Morris Pano, right, or other textbook, Floyd. And guys, then day after tomorrow there will be the quiz on number system, right? Complete syllabus of number system. Okay, tell me what is the answer for this question. What is the answer for this question? Convert 11011 gray code to binary code, right? 1 1. I think already I have convert now. Yes, as it is 0 0 1. This is what? 0. 0 exclusive OR with 1 is 1. 1 exclusive OR with 1 is what? 0. 1 0 1 0. This is the gray, and this is what? Binary. Gray and binary code. Okay then. Now tell me what is the answer for this question, everyone. Very, very simple question. Already we have in a previous class we have discussed. How are you, Chinmay? Decimal number 5137 is converted into binary coded decimal, Excess-3 code, 2421 code, 6311 code. Choose the correct statement. 5137. 5137. Everyone tell me what is the 5137. what is the BCD equivalent of 5137? Is it correct? So it is a MSQ actually. Or more than one answer may be correct. More than one answer may be correct. Or one may be correct. 5 BCD means 8421. Normally BCD means 8421 code. 8421 if nothing is mentioned. This is 5. Yes, this is 5. This is 1. This is 3. And this is what? 7. 5137. This is correct. Excess-3 code means what? 5 will become 8. 1 will become 4. So when I am saying that, actually is, this is what 1 actually. 1 is missing here, 1 is here. So this is the 5, this is the 8. Yes, correct. This is 1, this is the code for 4. It is also correct, Excess-3 code. This is 3 plus 1, 7, but it is 6 it is given. Sorry, 3 plus 3 is what? Excess-3 code. Na? 3 plus 3 is what? 6. 6 is given, 0, 1, 1, 0. It is correct. 7 plus 3, 10. 1, 0, 1, 0 is 10. Yes, it is a Excess-3 code. Excess-3 code. 5137, it is correct. Now tell me, in a 2421 code, 2421 code, now if you want to write 5137, then what is the 5? 2421. You can write the 5 like this. Right? Now 5. 1011. If it is right, 1011. Again it is correct. 2 plus 2 it is 5. Yes, it is also correct. 5. Then 1. 1 is written as 0001. Yes, it is also correct. 3. 0011 it is written. Yes, it is also correct. And then finally 7. 7. 7 is what? 1101. 2, 6 plus 1, 7. But it is all R111 written. This is wrong. This is wrong. Okay, easy. 6311. What is the 5? Right? What is the 3? 5351. 1 it is correct. 3 correct. And then finally what? 7. 7. 1001. 10. 7 is wrong. 7 is wrong here. It is not 7. This is also wrong. A and B are the correct answer. तो क्या होगा पता है? आपको लगेगा इजी क्वेश्चन है, बट इट विल टेक टाइम, इट विल कंज्यूम योर टाइम. तो आपको बी केयरफुल है कि एक बिट को क्या करना होगा, चेक करना होगा, अदरवाइज देयर मे बी द सिली मिस्टेक्स. ओके, इजी क्वेश्चन बट इट विल कंज्यूम टाइम. ऐसे क्वेश्चंस भी आते हैं, तो देख लीजिएगा जरा. और अगर आप यहाँ पर, मैंने कल आपको एक एग्जांपल बताया था, ये 2421 कैट सेल्फ कॉम्प्लीमेंट्री अगर कोड है तो बी केयरफुल अबाउट दैट. यहाँ पर कोई भी कॉम्प्लीमेंट नहीं है किसी का. 5137 1 is not the complement of 3 or 7 and so on. That's why we can write. Now this was the question. 3-bit gray code counter is given. 3-bit gray code counter is given. This is the A2, A1, A0. A2 is connected to the selection line of the multiplexer. A1 is selected to the selection S0 of the multiplexer. This is the MSB, because S1 is the MSB of the multiplexer. Then here A0 is connected to E bar. E bar means it is an active low device. When the A0 is 0, this device is active. If the A0 is 1, this device is inactive, because it is connected to E bar. E bar means it is an active low device. Then I0, I1, I2, I3, these are called the outputs. Now what will be the output at this point? What will be the output at this point? 0, 1, 2, 3, and this is given. 1, 1 means when we are getting the, there is no output at this point, the 5, there will be the no current through the R. When there is no current through the R, output will be what? 5 volt. 5 volt means what? 1. 1 is the output. It is written here. 1 means when this particular device is disabled, the current will not flow. When the current will not flow, output will be 1. Or when the device is enable, the current output will be I0 or I1 or I2 or what? I3. or we can solve. First of all, 3-bit gray code. 3-bit gray code means this is a 3-bit gray counter actually. A2, A1, A0. Already I have given how we can write the gray code. 0, 1. Reflection of this 1, 0. 0, 0, 1, 1. And then reflection of this 1, 0, 1, 1, 0, 1, 0, 0. Put 4, 0 here. And 4, 1 here. And that is the gray code. Now, A2 is connected to S1 and A1 is connected to S0. S1, S0. Now, A0. When A0 is 0, that particular device is enabled. And when the A0 is 1, this device is disabled because the bar is written. E bar means active low. So when it is 1, it is disabled. There will be the no current and output will be 1. So if suppose I am giving the 8 output function, this is the output, then when it is 1, output is 1. Because it is active low. It is inactive. When it is 1, A0 is connected to enable. When it is 1, it is inactive. Now, when it is 0, it is active. It will select 0, 0. 0 S1 0 0 means it will select what? I0. 0 1. Again, it is active. 0 1 means I1. 1 1 means what? I3. Then 1 0. 1 0 means I2. So I0, 1 1, I1, I3, 1 1, I2. That will be the answer. I0, 1 1. If there is any answer matched, I0, 1 1, I1, I3, 1 1, I2. 1 1, I2. This is the A. A is the answer for this question. So this is what combinational circuit. We are integrating what a counter. So you can say, sir, counter is a sequential circuit, but it is a simple given gray counter. Gray code counter means a 3-bit by a gray counter. That will be the counting. So first of all, here we are using the concept of what? Reflection. So directly we can write the gray code here. Gray code. It is the counting 0, 1, 2, 3, 4, 5, 6 and what? 7. And then selection line. And be careful about this active low. And then we can find the answer for this particular question, guys. So hope so you have enjoyed the session. Yes. Then in next class we will discuss what question. Tomorrow we are going to solve some important numericals, previous year question, some questions from the standard textbook. Ask your friend to join the session. And then for quiz. कल भी आपको solve करना, उसके बाद भी आपको आना है quiz में. Okay then. So it is a EAC Mains 2023, a practice course for electrical, electronics, civil engineering and mechanical engineering. Comprehensive coverage for complete preparation. क्या क्या प्रोवाइड होने वाला है? लाइव कन्वेंशनल प्रैक्टिस क्लासेस होंगी जहां हम आपको बताएंगे कि कैसे आंसर लिखे जाते हैं और कुछ स्टैंडर्ड डेरिवेशंस भी होंगे. ओके. और जितने भी आपके इंपॉर्टेंट सब्जेक्ट है, सभी सब्जेक्ट्स की क्लासेस लगने वाली है. तो अगर आपका इंजीनियरिंग सर्विसेज प्री आपने क्रैक किया है तो दिस इज द सेशन फॉर यू. साथ में है सीपीटी इवैल्यूएशन मींस कन्वेंशनल प्रैक्टिस टेस्ट. जो भी आप कन्वेंशनल पेपर देंगे उसकी कॉपी चेक होगी और आपको फीडबैक दिया जाएगा. लाइव डाउट सेशंस होंगे. ऑलरेडी क्लास स्टार्ट हो चुकी है. यू कैन इनरोल नाउ. पूरा कंप्लीटली फ्री कोर्स है ये. आप आइए और अपने मार्क्स इंक्रीज कीजिए. मैं एक्स IAS हूं. मैंने नंबर ऑफ टाइम्स मैंने इंजीनियरिंग सर्विसेज एग्जाम क्रैक किया है, इसलिए मुझे पता है जो मेंस है ना, जो कन्वेंशनल पेपर है उसका रोल बहुत ज्यादा है. वो आपकी मेरिट डिसाइड करेगा. ऑब्जेक्टिव में तो सब आसपास ही लेकर आते हैं, 5 नंबर 10 नंबर का डिफरेंस आएगा. लेकिन आप कन्वेंशनल में 50 से 100 नंबर का डिफरेंस क्रिएट कर सकते हो और आपके अपने सिलेक्शन को श्योर कर सकते हो. ठीक है, तो ध्यान रखिएगा. तो ये आपके लिए अच्छी अपॉर्चुनिटी है. कैसे आंसर लिखना है, टिप्स लीजिए कैसे लिखते हैं आंसर. तो दिस इज अ गेट 2023 रिजल्ट्स. 62 स्टूडेंट्स अंडर 50, 13 स्टूडेंट्स अंडर 10, 107 स्टूडेंट्स अंडर 100. तो चलिए आइए हमारे साथ और आप भी नेक्स्ट ईयर लेकर आइए extraordinary results in GATE and engineering services exam, guys. You are on BYJU'S Exam Prep. Thank you for attending the session. Please like the session, share the link of this session and subscribe our channel. Thank you and good night.